Alright, welcome back to Dividing Polynomials. Today we are covering synthetic division. Now this is another form of dividing, but we have to be very careful. In the previous part we covered long division. It will work for all type of dividing polynomials, any type of problems. Now synthetic, it will look easier, but the issue is it only works for certain cases. It only works for certain problems. And I will explain that after we finish with this example. Now, we have x to the fifth plus 6x to the fourth minus 24x to the third minus 22x minus 5 divided by x minus 3. Now, for any kind of dividing whatsoever, before we do any work for dividing, always check for missing terms. So I repeat, always check for missing term. So let's check for missing terms in this example. Since the problem starts with x to the fifth power, I'm going to count down by 1. 4, we have it. 3, we have it. 2, we don't have an x squared, so we need to fill that in. So I'm going to rewrite the whole problem. X to the fifth plus 6x to the fourth minus 24x to the third plus 0x squared. Now after x squared will be 1. I do have that x to the 1 power right here. So minus 22x to the 1 power. Now after just x, or x to the 1 power, is just a regular number, or also known as the constant term, minus 5. Alright, so the only thing different from the original to the one I just wrote was I filled in 0x squared, because in the original 5, 4, 3, then it jumped to 1, that means I was missing that 2. So now the one I wrote, 5, 4, 3, 2, 1, and then regular number, we're good to go. So let's set up for the work in synthetic division. Now the first part is I'm going to work with x minus 3. When we're working with synthetic division, we set our divisor equal to 0 and then just solve for x. So x equals positive 3. So again, when you're doing synthetic division, we set our divisor equal to 0 and then we solve for x. Now we're going to use this value to set up long division. Synthetic division. I'm going to move a little bit down here. Alright, so we're going to set up our synthetic division here. What I'm going to fill in this little box right here, this little L shape, is just the coefficient from here. So the first one, the coefficient in front of x to the fifth is just that invisible 1. The coefficient in front of x to the fourth is 6. So make sure you have spaces in between. The coefficient in front of x to the third is negative 24. The coefficient in front of x squared is 0. The coefficient in front of x to the 1 power, or just x, is negative 22. And the last part is just a constant term, so negative 5. So again, all I did was fill in the coefficient from the problem. So I drew arrows saying that I just pull the coefficient and just fill in this little box arrow L shape for synthetic division. Just the coefficient, meaning just the numbers. No need for variables. You'll need them when we are writing out your final answer. Alright, so the process is our first number right here, our first number, we always bring it down. So 1. From there, what I'm going to do is I use this number that we have, that we saw for x, and I'm going to multiply it. So 3 times 1 is 3. So I'm going to put the 3 underneath the 6. If it's positive, I'm going to put a plus right here. So now we have 6 plus 3, which is 9. Alright, I'm going to repeat the process. I'm going to use this 3 again, multiply to that 9. So 3 times 9 is 27. So I'm going to bring that 27 and put it over here. Since it's positive, I'm just write a plus in front of the 27. Then I'm going to do negative 24 plus 27, that will be 3. And then I'm repeating the process. So 3 times this 3 is 9. So I'm going to put this 9 over here. Since it's positive, I'm going to write a plus. So 0 plus 9 is just 9. And then repeat the process. So 3 times 9, this 9 right here, is 27. So I'm going to put this 27 over here. Since it's positive, I'm going to write a plus on that 27. So we have negative 22 plus 27, which will be 5. Then, one more time. 3 times 5 is 15. So I'm going to put the 15 over here. And since it's positive, I'm going to write plus. Negative 5 plus 15 will be 10. This is our remainder. And we're right here. Remainder. Alright. So I just finished doing synthetic division on this problem. Just to review, when I was doing these multiplication with this 3 and the numbers I had here, I put it in the middle row and then I just combined the numbers vertically. So 6 plus 3, 9. Negative 24 plus 27, 3. 0 plus 9, 9. Negative 22 plus 27, 5. Negative 5 plus 15, 10. So again, I just combined the numbers vertically. This 3 is what I multiply to the numbers I get at the end. So I have my work right here. When you reach to the last number, the 10, which is our remainder, now we're going to set up our answer. So, in order to set up our answer, one thing you got to remember. For synthetic division, since our problem started with x to the 5th, our answer will start with 1 less of the exponent. So I repeat, since the problem started with x to the 5th, your answer will start with 1 less than the exponent. So again, your answer will start with 1 less than the exponent. Since we have a 1, I'm going to write 1 x to the 4th, because that's 1 less than the original problem. Next is positive 9, so I'm going to write plus 9, and then we're going to count down. So x to the 3rd, then 3, so plus 3, x squared, and then plus 9, just x, or x to the 1 power, which is fine. And then after x to the 1 power is just a regular number, so positive 5, so plus 5. Alright, we're almost done. The remainder, we have to include that. Since it's positive, I'm going to write plus, put it on top of the fraction, and then the denominator will be our divisor, x minus 3. So that is your final answer. So again, our answer started with 1 less for the exponent from the original problem. Then I just use the coefficients to fill in our answers, and then I count down with the exponent. So that's all we have to do. And then the same thing as long division, when you have a remainder, put it in the top of the fraction, put it in the numerator, and then put our divisor in the denominator, or at the bottom. Now, I mentioned before that synthetic division only works for certain cases. Now let me talk about those certain cases. It's depending on your divisor. This one right here, x minus 3. Now, the exponent on the x is the invisible 1. So, synthetic division only works if the degree, the leading degree, or degree of the divisor is only 1. I repeat, only 1. So again, synthetic division only works if the degree of the x is 1 and an invisible 1 coefficient. So, the degree of the x, or the variable, has to be 1 and the coefficient has to be 1. If there was a number in front of it, for example, 2x plus 7, well, it's going to be hard working with that kind of divisor. You can get x by itself. It will, and then what I would do is convert it. It will be x plus 7/2. If I use that, I'm going to be doing more work because we're going to be working with fraction. So that's why it's best that to use synthetic division when the coefficient in front of x is 1. Now, the degree, for example, x squared plus 4, since the degree is more than 1, we can't use this because it's not going to align with the work. So you would have to use long division if it's x squared plus 4, or if it was x to the third minus 6. Since the degree is more than 1, again, we cannot use synthetic division. It will not align with the numbers, therefore the work will not align, will mess up, and you won't get the right answer, or most likely you won't be able to finish the work. So again, synthetic division only works when your divisor, the degree of your divisor is 1 and the coefficient is 1. If your coefficient was like 2x plus 7 or 5x minus 1, then you would have to convert into a fraction, and that's going to be more work using fraction. So again, synthetic division only works when the degree is 1 and the coefficient is 1 on the divisor. Nothing else.